Hello guys, in previous lecture we will study the reducing agent, that is lithium aluminum hydrate. This lithium aluminum hydrate, it donates the H minus ion. And what is the role of lithium aluminum hydrate, that is LaH, instead of different polyfunctional groups? Okay. Now in this lecture we study the another reducing agent which is also hydride donor. It is a reducing agent which is also a hydride donor, that is sodium borohydrate. That is sodium borohydrate. This sodium borohydrate is also donated the H minus ion, that is it also donates hydride ion. Okay, this sodium borohydrate we use instead of lithium aluminum hydrate. We use instead of lithium aluminum hydrate, but lithium aluminum hydrate, it is a more reactive. Now we can say that it is a more, it easily gives H minus ion than sodium borohydrate. Okay. Then what is the reason behind it? Because lithium aluminum hydrate is more reactive than sodium borohydrate, which depends on the size of central metal atom and size of boron. Okay, in this lithium aluminum hydrate, the aluminum shows the larger than boron, therefore bond angle goes on increases in aluminum, therefore lithium aluminum hydride, it donates the H minus ion easily than sodium borohydrate. Okay, this sodium borohydrate is also known as a sodium borohydrate NBH, or it is also SBH. Okay, then this sodium borohydrate, that is SBH or NBH, is a highly selective reagent. It is highly selective reagent because by using this sodium borohydrate, it does not reduces all polyfunctional groups, but it only reduces the selective functional groups in their respective amine, in their respective alcohols. Okay, but in case of lithium aluminum hydride, the lithium aluminum hydride is not a selective reagent because maximum polyfunctional groups it undergoes reduction by using lithium aluminum hydrate. Therefore, the sodium borohydrate is known as a highly selective reagent. In this reagent, or by using this reagent, we can reduces some groups, or as well as some are non-reducing functional groups. Some functional groups are reduced by sodium borohydrate and some are non-reducing functional groups are here. Then in non-reducing functional groups, in this case, what is the most important non-reducing functional group? It is a ester. It is a ester. Ester is not reduced by using sodium borohydrate, but in case of lithium chloride or by using aluminum chloride in diglycine solvent, this is a solvent and this is a typical condition used for the reducing the ester by using sodium borohydrate, by using this sodium borohydrate as well as lithium chloride or aluminum chloride in diglycine solvent is also used. By maintaining this condition, we can easily reduce the ester into alcohol, 2 molecules of alcohol. Okay. The second is a non-reducing functional group. It is a carboxylic acid, or commonly it is known as a acid. Third one is a amide. The amide is also a reducing, it is a non-reducing agent, and here it is a reducing groups. Ester is not reduced, but this typical condition, ester is also reduced. Acid, it does not reduce by using sodium borohydrate, as well as amide is also not reduced by using sodium borohydrate. Then after that, then the carbon-carbon double bond, that is a multiple non-polar multiple bonds, carbon-carbon triple bond, as well as carbon-carbon triple bond, that is cyanide. These functional groups are not reduced by sodium borohydrate. And the reducing functional groups are, that is, first one is a aldehyde functional group is also reduced. Then aldehyde undergoes reduction by using sodium borohydrate. Then it gives primary alcohol. Then second, it is the most important, that is a ketone. Ketone undergoes the reduction by using sodium borohydrate. Then it gives a secondary alcohol. Third one is a alkanoyl chloride. It undergoes reduction reaction by using a reducing reagent, that is sodium borohydrate. Then it gives also primary alcohol. These are the some reducing groups, reducing functional groups. It is reduced by using sodium borohydrate. As well as azide group is also reduced, as well as carbon double bond N, this group is also reduced by using sodium borohydrate. Okay. After that, we take some common examples for these reducing agents. This reducing agent, it is a selective reducing agent used for the reduction of different functional groups. Then first, we can consider the aldehyde. This is a aldehyde. Aldehyde undergoes the reduction by using sodium borohydrate. This sodium borohydrate is used in presence of methanol. In this case, there is a methanol, that is MEOH, or it is also written in this form CH3OH, that is, or THF, or water. These are the used as a solvent, because in these solvents, this solvent is a polar protic solvent. These are the polar protic solvents. In these polar protic solvents, the sodium borohydrate, that is SBH, sodium borohydrate, it is a soluble. Okay. Therefore, because of this solubility, we can use the methanol, that is alcohol, then water, or ethanol also used. THF, which is a non-polar solvent. Therefore, this is not used with sodium borohydrate. Then methanol, ethanol, and water. These are the polar protic solvents are used with sodium borohydrate. Therefore, this methanol we considered here. After that, the acid hydrolysis is also useful for the reduction of aldehyde. In this case, the sodium borohydride, the structure of sodium borohydride is Na+. Na+ is in form of salt. This is a boron. This one is a hydrogen. This one is a hydrogen. Then hydrogen and hydrogen. Okay. In this structure, the BH3 is an example of incomplete octet. Then, therefore, the boron is attached to the 3 hydrogen atoms. After formation of boron, then the octet of boron, it does not complete it. Therefore, it is an incomplete octet. Therefore, boron shows the electron deficient characteristic. Therefore, it shows the partial positive charge. Then the hydride H minus, it also easily attacks on the boron. Then this hydride comes from the sodium hydride. Therefore, this BH3 is reacted with sodium hydride. Then we can give the sodium borohydride NaBH4. Okay. Then this fourth hydrogen, it comes with a negative charge. Therefore, after bond formation between boron and hydrogen atom, there is a octet of boron. It should be completed. By completing this octet, those two electrons are also goes on increases. Therefore, boron shows the negative charge. This is the structure of sodium borohydride. Okay. In this structure, the boron shows the negative charge. Therefore, boron it is a central metal atom. Okay. Therefore, this sodium borohydride it gives the H minus ion. In this aldehyde, the mechanism of this reaction is there is a carbonyl group is here. This carbonyl group, the carbon contains the partial positive charge, oxygen contains the partial negative charge because the electronegativity difference between carbon and oxygen is a greater. Therefore, oxygen attracts the shared pair of electron towards itself, and carbon it donates the electron to the oxygen atom. Therefore, this carbonyl carbon it is a electron deficient carbon. Therefore, this hydride it attacks on the carbonyl carbon atom. At that same time, the pi bond is delocalized on the oxygen atom. After delocalization of oxygen, there is a formation of O minus, then hydrogen, then hydride and carbon. This new bond is generated. Okay. Then there is a formation of alkoxide ion. After that, it undergoes acid hydrolysis. That means this hydrogen is coming from the sodium borohydrate. This hydrogen is coming from the sodium borohydrate, and there is a negative charge, negative oxygen is here, and it undergoes acid hydrolysis. From this acid hydrolysis, the H plus ion is also available. Therefore, this oxygen attacks on the H plus ion, and there is a formation of alcohol. That means this hydride comes from the sodium borohydride, and this hydrogen coming from the acid. We know the H plus ion comes from the H plus ion. Then this is a mechanism, as well as the aldehyde is undergoes the reduction reaction by using sodium borohydride in presence of methanol or ethanol or water. These are used as a solvent, and it followed by acid hydrolysis. Then we get the primary alcohol. Okay. Then next example is ketone. This is a ketone. When ketone it undergoes reduction reaction in same condition, same solvent, followed by acid hydrolysis. Then it gives a secondary alcohol. After that, alkanoyl chloride or acyl halide. This acyl halide it undergoes the reduction reaction by using sodium borohydride in presence of methanol, and it followed by acid hydrolysis. Then it forms also primary alcohol. Okay, this is a primary alcohol, 1-not alcohol. Then this is also 1-not alcohol, or it is called as a primary alcohol. In this functional group, the hydride ion it donates the hydride to the carbonyl carbon atom. At that same time, the pi bond is delocalized on the oxygen atom. After delocalization, oxygen shows the negative charge. Then structure is that Cl and one hydrogen, that is hydride coming from the NaBH4. After that, it undergoes the acid hydrolysis. The bond it should be break down. Then one hydrogen goes with hydrogen oxygen atom, and another hydrogen goes to chlorine. There is a formation of primary alcohol by the elimination of Cl or by the elimination of halogen. The halogen it should be eliminated because it acts as a base leaving group, therefore Cl minus it should be eliminated. Okay. Then another functional groups are after that azide. Azide, it also a reducing functional group. Then this azide, it undergoes the reduction reaction by using sodium borohydrate in presence of CH3OH or C2H5OH or water, followed by acid hydrolysis. Then it gives a primary amine, or then it gives a amine. Okay. After that, there is a imine, RCH double bond ANH. This is a imine. This imine is again reacted with sodium borohydrate by using solvent, it followed by acid hydrolysis. Then this imine get converted into primary amine, because from sodium borohydride it donates the H minus ion, and this H minus ion donates to this carbon atom. Okay. After breaking of this pi bond, there is a one hydrogen is attached here, another hydrogen is attached here, bond followed by the acid hydrolysis. That means the imine get converted into primary amine. Okay. These are some important functional groups is reduced by using a sodium borohydrate. Okay. After that, we study some examples according to these functional groups. Okay. Then first example is OH. The name of this compound is 1, 2, 3, 4. That means 3-oxy butanoic acid. 3-oxy butanoic acid. It undergoes reduction reaction by using sodium borohydrate. Also, we can use a methanol, ethanol, or water, followed by acid hydrolysis. Okay. We know very well is that the sodium borohydrate does not reduces the carboxylic acid functional group. Therefore, after conversion of product, the carboxylic acid stay as it is, or it remains as it is. But in this case, there is a carbonyl group is present. This carbonyl group undergoes the reduction reaction, and this carbonyl group get converted into CH2 group. Okay. Then product is the CH3CH2CH2C double bond OH is formed. That means the butanoic acid is a product of this reactor, that is butanoic acid. Then second example is that there is a CH3 C double bond O, CH2 CH2 C double bond O, then C2H5. The name of this compound is 1, 2, 3, 4, 5, 6, 7 heptane 2,5-dione. It undergoes the reduction by using sodium borohydrate and methanol followed by acid hydrolysis. In this reactor, there are two carbonyl groups are here. these two carbonyl groups, that is C double bond O group, get converted into CH2 group, as well as CH2. These carbonyl group get converted into CHOH group. Okay, this carbonyl group get converted into CHOH group. Then correction is here. There is a CHOH. Then this carbonyl, in this example there are two carbonyl groups are present. Then each carbonyl group get converted into CHOH form. This C double bond O group get converted into CH, and this carbonyl group is also get converted into CH. Then product is a formation of diol. Formation of diol. This is a OH, H, C2, H5. Okay. The name is heptane 2,5-diol. Heptane 2,5-diol. Okay. After that, we can take the unsaturated aldehyde. After that, we can take the unsaturated aldehyde, that is CH double bond CH, CH2, then C double bond OH. Okay. The sodium borohydrate is a highly selective reagent. It does not reduce the double bond as well as carbon-carbon triple bond. Okay. Then it reduces the carbonyl group. From this carbonyl group, that means the aldehyde is get converted into primary alcohol. Then this product, it undergoes the reduction. Here we can use a water followed by acid hydrolysis. Then this aldehyde group get converted into primary alcohol. But the CH double bond CH, it does not undergo the reduction, because by using sodium borohydrate, this functional group is not reducing functional group. There is a CH2, then CH2OH is formed. There is a formation of this alcohol. That is a, from unsaturated aldehyde we can prepare the unsaturated alcohol. Okay. After that, we can take a next example, that is CN CH to CH2 C double bond O CH. In this molecule, the cyanide functional group is attached to the terminal end of carbon atom. Okay. It undergoes the reduction reaction by using sodium borohydrate. This cyanide, it does not undergo the reduction reaction. Therefore, in the product, the CN remains as it is. Then CH2 group get converted into CHOH group, and there is a formation of secondary alcohol. There is a formation of secondary alcohol. Okay. Then next example is cinnamaldehyde. Cinnamaldehyde means benzene. Then CH double bond CH, that is a alpha beta unsaturated carbon here. Then C double bond O hydrogen is here. This molecule is a cinnamaldehyde. Okay. It undergoes reduction reaction followed by acid hydrolysis. This aldehydic functional group get converted into primary alcohol. This unsaturated carbon atom, that means the multiple double bonds, non-polar multiple double bonds, is not reduced by using sodium borohydrate. Then this sodium borohydrate not reduces the double bond, therefore CH double bond CH remains as it is. Then CHO, that is aldehydic functional group, get converted into primary alcohol. Okay, this molecule is known as a cinnamon alcohol. This molecule is known as a cinnamon alcohol. That means the aldehyde group converted into cinnamon alcohol. Okay. After that, another example is CH3C double bond N, then CH2 to CH3. This is a carbon double bond nitrogen group is here. Okay, this carbon double bond nitrogen group is also reduced by using sodium borohydrate. It undergoes the reduction reaction by using sodium borohydrate by using water, methanol, ethanol as a solvent, as well as it followed by acid hydrolysis. Then this C double bond ion, it undergoes the reduction reaction. That means this hydride, it donates the hydride ion attacks on this carbon atom. Then one hydrogen is attached here, another hydrogen is attached here. Then there is a formation of product. Then this product, then double bond undergoes the reduction. Then it forms a single bond. There is a NH, NH, CH2 is here. Okay, there is a formation of amide. Okay. Then most important example, that is C double bond O, OR, that is a ester. In primary stage, the sodium borohydrate does not reduce to ester, but in some changing the condition of this reaction, that means the sodium borohydrate is also used in presence of lithium chloride or in presence of AlCl3 in diglycine solvent. This is the most important reaction for JEE NEET as well as CET exam. In this reaction, there is we can't use the methanol, ethanol as well as water. Instead of this polar protic solvent, we can use the lithium chloride or aluminum chloride. Okay, but in diglycine solvent. After that, this ester get converted into primary alcohol as well as second molecule is also alcohol. Okay, there are two molecules of alcohol is formed. Okay, these are the some examples of functional groups which is reacted with sodium borohydrate, and most important and last functional group, that is a alkyl halide. Okay, that is alkyl halide. Okay, in case of alkyl halide, there is a CH2X secondary alkyl halide, that is a RCHR, and that is a X, that is a secondary alkyl halide, and third one, it is a CXR and R. This is a primary alkyl halide, this one is a secondary alkyl halide, and this one is a tertiary alkyl halide. By using sodium borohydrate, it undergoes the reduction reaction by using a primary alkyl halide. But this sodium borohydrate does not show the reaction with primary alkyl halide. There is no reaction is shown with primary alkyl halide, and this is the most important point. Okay. But in secondary alkyl halide, the secondary alkyl halide, it undergoes the reduction reaction. Then it gives a alkane. Then this is a R group is here. Then CH group get converted into CH2, because then it gives alkane. By using sodium borohydrate, the secondary alkyl halide, it is converted into alkane. Because the reason is that the sodium borohydrate, it donates the H minus ion in between halogen and carbon atom. Halogen shows the partial negative charge, carbon shows the partial positive charge. Because the halogen shows the electronegativity, therefore there is a electronegativity differences here. That means the carbon in between carbon and halogen atom, there is a polar bond is formed. Because of this polarity, this hydride donates the this carbon atom. At that same time, the halogen, it should be eliminated, because halogen, they will consider the chlorine or bromine, it acts as a base leaving group. That means this halogen is replaced by hydrogen in secondary alkyl halide. Okay. Then next one is a tertiary alkyl halide. When tertiary alkyl halide undergoes the reduction reaction, by using sodium borohydride. In previous lecture we can use the lithium aluminum hydride. By using lithium aluminum hydride and tertiary alkyl halide, the tertiary alkyl halide get converted into alkene, but in this case the alkene is not generated. Okay, alkene is not generated. By using sodium borohydride and tertiary alcohol, there is a formation of alkane. This is a main difference between tertiary alcohol. It is reacted with sodium borohydride and lithium aluminum hydride. Once again, I will repeat it. The tertiary alkyl halide is reacted with sodium borohydride followed by acid hydrolysis. Then it gives a alkane. And if the tertiary alcohol is reacted with lithium aluminum hydride followed by acid hydrolysis, then it gives alkene. This is the main difference between lithium aluminum hydride and sodium borohydride with tertiary alkyl halide. Okay guys, this is the second reducing agent, that is second hydride donor, that is sodium borohydride. Okay, but last and most important point of this reagent as well as lithium aluminum hydride, the reactivity order of these reducing agents is, that is lithium aluminum hydride is more reactive than lithium borohydride, than sodium borohydride, and then sodium cyanoborohydride. Okay, this is a important and this is a reactivity order of hydrides. Okay, the lithium aluminum hydride is more reactive than LiBH4, than NaBH4, than NaBO3H. Okay guys, this is the reactivity order of hydride donors, that is reducing agents. Okay, these are the second reducing agent, that is sodium borohydride, and first one is the lithium aluminum hydride. Okay, thank you.